The adapter pattern allows us to adapt one type of interface to another. It basically bridges incompatible interfaces so that they can work together, like maybe integrating third-party libraries into our code, maybe integrating some legacy code, or maybe some APIs that have different structures. It is very popular in typed languages, but it's also used in JavaScript. Say we have a website with some payment integration in it, like Stripe payment. And we've built our entire app to work the same way as Stripe is working. So all our methods are the same, like pay, refund and cancel. And everything is great because we are mapping one-to-one the relation between our application and the PayPal API. However, very soon we need to add a new payment provider, like Stripe, which suddenly has a completely different API interface, which means that we cannot just use it in our application because the interface that we are accustomed to and the interface that Stripe has is completely different. We can adjust our app to support both interfaces, but adding a bunch of if-else's in every method, we can very soon see how this is not very sustainable and practical. But not all is lost. What we can do is we can add an adapter right in front of this class, and that adapter will fit exactly into our interface, so that we can just plug it in our application. Our application will work just fine because our adapter will then take the responsibility of adapting this class into our existing application. That way we don't have to rewrite an entire application, and we don't have to rewrite this third-party library, which is probably maintained by somebody else. This design pattern is used a lot for adapting API responses into some expected format. If we suddenly need to change a third-party API or implement another API for logging or data submission or storage or search or whatever, we can just adapt the API format into something that our application already understands. And the same goes for different user interface libraries. If we are switching from Bootstrap to Material or something similar, we could use an adapter to map old class names to new ones if that makes sense, right? We can adapt different date libraries if we need to support multiple at once, and we can use different loggers, different payment shipping, image manipulation, authentication services, which is something we will actually work on in the skill build module later. Obviously, best way of using this design pattern is by planning on using it when we know and expect to support different types of interfaces. That's why it's important to know it, right? Like when we know that we might have a different payment provider or additional service, we should start with a simple adapter and then just expand later, rather than having to implement it after the fact as an afterthought. But this is the essence of the adapter pattern. It allows us to integrate with some third-party services that could have a completely different way of working without changing our application, without modifying, and also without modifying that third-party service, because it's just not practical at some point. It has the biggest benefit. It's good integration. We can integrate completely different things into our existing application, which comes quite often handy. Second benefit is the reusability rate. We can reuse existing code with some new systems, some new libraries, saving us a lot of time and effort. The next benefit is ease of maintenance. We are isolating the logic of adaptation from our application and also from the third-party libraries. This is very useful. And the next benefit is extendability. We can add as many new services or APIs as needed without having to worry if we're going to change our application. Scaling is as easy as adding new adapters for new services that we need. Some trade-offs of this design pattern are increased complexity. It's obviously because we need to add another object to essentially do translation between two objects, two different interfaces. So we risk increasing complexity for maybe adding new functionality. Another downside is that it could hide the real problem. So instead of refactoring the original code to ensure consistency, to ensure that our application is doing things properly, we might just reach out to the adapter and say, well, okay, we can just slap an adapter to it and call it a day. It's much easier than to actually solve the problem that might occur. So make sure to always use it by design. And the next disadvantage is that it could delay migration that is needed. Sometimes we might again reach out to adapter as a temporary fix. Let's say when we are migrating to a new system and then we just leave a lot of technical debt that's sitting there and just waiting to explode because it was easier to use the adapter. So make sure that you learn exactly when to use adapters, and not for something that will hide the problem or maybe just make technical debt, but for something that will actually increase the usability over time. In this lesson, we will look at one concrete real-life example where adapter could be used. Now, this example is about adapting different API points, in this case books, but it could be really anything. I had to do something similar to this in my previous job, probably 10 years ago. So this solution got me a lot of kudos from my older colleagues, meaning that they liked my way of thinking, and then they invited me to parties and whatnot. Just kidding, developers who master design patterns do not get invited to parties. Anyway, here we have a situation where we have a service of fetching books, right? So we are retrieving books from the backend. Now this is most likely your own database, your own backend, and somewhere you're gonna have to put the titles of the fields or the names of the fields like ID, title, author and year. So this is a specific format that our application works with, and life is great. If I go to the Chrome, we can see now that this object is returning the author, ID, title and a year as we've shown in the code. Now at one point you will be asked to add another book service provider, in this case the Google, for example. So you might search for additional books or maybe just fetch some additional information, some additional details to those books. Now I've already imported this books Google service here, and I'm just simulating this so that we don't have to work online and call the actual Google service. And this is just another module that I'm importing here, and we went over modules so we know how modules work. Now I'm going to log both Google Books and our own book here to see what's happening. And as we've seen in the console, now these objects differ quite a lot. There is one level for the regular books where there is author, title and year, but for Google Books there is additional level about volume information, and then additional level about authors because there could be several, and then there is a title and published date there as well. Now this obviously causes a bit of problem for our application, because if we are now going to log only the book title, here we get clean code, but for the second one we don't get the title, and that is because our show book title method here, so this is basically the front-end application, somewhere you're going to say book.title. This show book title does exactly that thing. It logs the book.title, and since for Google this title is on different level, it will not work. It will give us undefined here, because the title for Google Books object does not have a title at the same level. And as we have seen in the console, there is a difference in structure here. Now, how can we solve this? Well, obviously, the easiest way is that where showing the book title, we can just put or book.volume information.title there. Now, if I go back to code, to the browser, we can see that it works now. We get the clean code, this is from our internal library, and we get the pragmatic programmer from the book service. Now, you could see the problem here is that we have to accommodate for each and every combination here. And that's not the best way of doing this, right? Because apart from title, there is a year, there is author, there is ID, there's many other fields that we need to change our code for on all possible pages. This is only one function, but we are displaying our book in 5 or 10 different places in our application. We could as well, instead of doing this, let me just revert it, we could go into our Google Book service and actually change here, so that we, instead of returning this as it is coming from the server, we could have a mapping here. We could have a different return here where we're going to return something like ID. It would be something like server data, book ID, and then the same for title, server data.title. Now, changing the third-party library obviously has risks on its own, because as soon as we have made this change, we are either never going to update this library from the server, which is not the best case because once the Google service changes, these changes will not follow. Or when we update it, we have to manually go in and copy this into the new version and then figure out how to do that in the new version. And that's just bad, because if we change it once, we are either never going to update it, or because that will remove our code, or we will have a lot of overhead each time we update to migrate these changes. Another option would be to just put if else wherever we are going to map this data. So here we could have a wrapper just changing Obrisho. So this is obviously not the most ideal solution. But we could look at our custom service data and say, well, why don't we just format this so that it has the volume information and then move the title in that one and move the author and year and everywhere there, and that's fine. But then we are relying that Google will keep their promise of their own data in the same format. And you see where I'm going with this. What happens if we add another service then? Are we going to change our code to match 2 other services? How it will handle 3 or 4? And also, how are we going to adapt our database in our backend? Will the front end be completely different from the backend? There is a lot of complications here. But I wanted to pause this course a bit here and think, how would you solve this problem with this code so that we can add additional service with a different format and at the same time not have to change our application every possible place where we want to show the title property, like in this show book title. If you get stuck, rather than Googling or using ChatGPT, please visit the community section on the website first and see if other students have shared their solution. Maybe you can get some inspiration there. But also think about the solution for a few moments and maybe write some code in the editor or maybe on paper if you want. And in the next video, I will show you one way how to solve this with the adapter pattern. Let's look at one theoretical solution on what problems does the adapter pattern solve. Here we have an authentication example where our application uses email to authenticate users towards our database. So this could be any type of application that has some way of authentication, like my page or blog or forum or our website, whatever. Now in our application, we just call methods that our services uses. In this case, we have the login, register and logout. And life is great, but we already know the problems we have. We need to implement another way of authenticating our users. In this case, it's Google Sign-in, and it has its own authentication system. And this would obviously not be a plug and play because Google Sign-in has a completely different ways of doing the same actions, doing the same things that we are doing. So instead of login, they have authenticate. Register, they have create user, logout, they have sign out and whatnot. But there could even be several methods, an entire process for doing one thing that we are doing in our application, like this of creating users. There could be many methods that you need to call for it. So it's not just the name of the methods as we've simplified here. There are several things happening here. Now this would obviously not work with our application as is, because it's completely different interface. It is still the login functionality, however, we are talking about, so it's not completely out of the context. It's just not plug and play. This is where we could use the adapter pattern and make another object, in this case Google Sign-in, work with our application. So this is obviously not going to work like this here. We cannot just use it because let's say that registering user requires several calls of different methods like we have here. So what we are going to do is we are going to make one adapter here between our Google Sign-in and the application and map that new library and things that we are trying to integrate, in this case Google Sign-in library, and map it into the existing field that our application can work with. In this case, the method that's called register, because that's what we have here and what we have in the beginning where we started. And in it, we are going to adapt and we are going to call whatever is needed from the Google sign up to achieve the same registration functionality. And our application, we just call these methods as usual. We probably need some logic here to support different adapters, but it's not as complicated as to integrating support for a completely new service, because that would mean, again, changing all of our code or maybe changing the service or something like that. We will see a few more examples later in the skill builder module, so make sure to watch at those lessons. But in essence, the adapter pattern is a way of adapting some type of interface, like in this Google sign-in case, with its unique methods and its own procedures, to some other interface, in this case our application here, that already has a specific interface that we use in our application. Let's solve our problem with different book interfaces with the adapter pattern. One way of solving this is by just making a class that will take the book and then transform it or map all the values so that they are the same format as our custom book service. So I could make one class here, Google Books adapter, and it will in the constructor get, sorry, I put a function here. We can name this a class, constructor, and it will take the Google Books that are already fetched from the service. And then we will say just this ID equals Google Books ID, because that's where it is. We have this title. Now the books data, it's inside the volume, info title. And I will do the same for authors. Well, actually authors is a string in ours, so we need to check if it exists. And if it does, we are just going to join with a comma. But if it doesn't exist, we are just going to put some undefined or something. I have to do the same for year. And since it's a date at Google, I will just put this code that will separate the date and gets us the year. So this is just a simple hack to get this data back. And then after we have received the book from Google Book Service using this fetch book here, so we are fetching the book by some other ID, we could just wrap it in something in our adapter. So I will just call this book row, for example, doesn't matter. Here it will be a Google Book, which will take new Google Books adapter, and it will pass in the row data and then get it back with the Google Book. Now, with a bit of luck, if I try this in a browser, we can see that the Google Book has author ID and a year in the same level. Google Books adapter has the same thing, author's ID, title and a year. I'm kind of missing a title here, I see now. And that is because I removed a bit too much. I removed this title here. So now we see that there is author, title and a year, and the Google Books adapter, author, title and a year. But we also see these two here, which say that the clean code and the pragmatic programmer are titles that are being retrieved from our code and being displayed here. And in our code, there is this show book title, which now only logs the book.title, because now we have mapped the volume info title into what we need, just a top level title property. And this is pretty much the simplest way of using adapter pattern to, well, basically adapt one interface to another. So how this works and what's going on here? Let me just go through the code. We have the Google Books service here, which is in a different file, and it has different structure. We also have our custom book service here, which has as well different structure, or a structure that our application can work with. This is coming from our backend, from our database. In this case, we are just returning one book here from the backend, and then we are again fetching the Google Books service here, but we are using the Google Books adapter, where we are doing whatever we need with the fetch data from the backend. Like in this case, we are joining the authors with a comma here, because there are multiple authors. Our local database does that automatically, probably. We also see that there is a need for this year in our application. The Google, however, does not have the year, it has the published date. And this published date is a different format, so what we're doing is that we are actually formatting this year to suit our needs better. And then we are still fetching the Google Books service from the backend. That's fine. We've done that so far as we used to do. But then instead of using that raw data from the server, we are actually
running it through the adapter, which will then map all of our fields, right? And then we are using that Google book in the show book title here at the end, just as we did before. But before we got the undefined here because the Google title was on different place. But here now we can see that the title is in the same level, like here, for example, Google Books adapted, the title is in the root, but also here in our local, the title is in the root, so the application has no problem of fetching and displaying that data. And we can see that we have the exact same structure and that we can obviously use this new object in our application as is, because our application is already used to, and it works just fine with this type of interface, with this type of object structure, right? And this is pretty much everything there is to adapter. We are just using it to, well, adapt different interface to something that we need to work with. In this case, it is just an object with properties. We could adapt methods as well, some functions. Maybe Google has a function of retrieving the more information, and our own object has something like fetch new information, something like that, and we could map those and we could match them so that our application can just continue working with the structure it is already familiar with. Let's look into a few real-life examples and applications where this design pattern is used. And the first example I have is this Ember.js, a JavaScript framework for creating ambitious web applications. Very catchy title, whatever that ambitious means. But anyway, they use adapters and serializers to connect to any backend stack. So if we open the documentation here, they actually talk about embedded data flexibility and text-to-use of the adapter pattern. Ember data can be configured to work with many different kinds of backends. And there is even entire ecosystem of adapters that you can use. So if I open this, we can see that they have something for the Django, local storage, GraphQL, JSON, local forward, etc., etc., etc. Some are work in progress, some are ready. But these adapters basically determine how data is persistent to a backend data storage. There is obviously the front-end application that has a structure that it wants, but it could connect to different adapters, to different backends here, with the help of adapters actually. So things like a host URL format and some other things can be defined here in the backend. This is very practical because we can just use the interfaces. And here in their code, we can see examples of usage. We can just connect it to different backends, but then we can just fetch all the drafts here, right? Because this adapter knows where the drafts are and knows how to convert them from the backend into our application, into our frontend. And all the functionality from the frontend here, like this fetch, will then work just fine. And this find all posts, for example, will work just fine because this application, with the help of adapters, knows how to use these methods and knows where to find data. And it's a very cool way of reusing the same frontend or functionality or components for different projects, because we can just adapt a different backend to it and it should work just fine. The second example I have is this Gatsby, and this is the best React-based framework with performance, scalability and security built in. And I never used it, but I can see in their source code they have these packages called the adapters actually, and it creates different adapters in its sub-packages, one of which is this Netlify adapter here, where we can see different options this package configures when working with, for example, images. There is this image CDN, and there are different ways to store these images and to restore them and get the cache URL. But the point is that if Gatsby uses some features here from Netlify, but if one day Netlify maybe gets a better competitor or changes their backend, or Gatsby wants to implement something else as an alternative, someone could just develop an adapter here for Gatsby, and the end user would not even know that this has happened. There will be no changing requirement in our application. We could just switch to a new service, and all this functionality for Gatsby will still work fine. And third example here on the backend, I have this Waterline. which is a adapter-based ORM for Node.js to support different databases. So it supports MySQL, Mongo, Postgres, MS SQL. Even though these databases have similar syntax, it's not exactly the same, and that's why we have abstracted their functionality with additional layer of adapter. And by nature, the adapter has much more use on the backend due to the nature of services that are used in the backend. But if you're not familiar with ORM and active record design patterns, I recommend checking them out. Although they're not used very often in large applications, they're very good for rapid development. Anyway, the waterline allows us to connect with different databases with same syntax, and even allows us to change from one database to another without changing anything in the code. So only one variable is needed to change, and you can switch entire databases. Although I've never ever in my life switched the databases live, but there are use cases where you might need to do that when you are making application that other people could install and you want to support multiple databases. And it does all that via adapters. So when we use waterline, we call this in their documentation, which is on a different website. They actually have these examples of calling the database by saying the zookeeper find, again with the animal examples. But they have different adapters here where you could just plug in the MySQL, Postgres, Mongo, etc., etc. And some of them might have some specific functionality, but you just create queries as you would with any of those adapters. You just say find by this parameter and limit 30, and this will be, with the magic of adapters, translated into specific database here. And you could even make your own database supported or your own backend services. They're popping up now lately. And what you would do is you would just follow all the documentation that they need and all the methods that they use. So by you writing an adapter to it, you would match your interface with the expectations of Waterline library, and everything will work just fine.
Let's do a quick summary of the adapter design pattern. Do you remember what the adapter pattern does? It's in its name. It is an adapter. So it adapts different objects and allows objects with maybe incompatible interfaces to work together. If our application works with a certain format of a, let's say, backend API or maybe some service, and we want to use some other type of data without changing the entire application, we can just adapt the new type of object into our application, into what our application expects. And if done correctly, we're good to go. Now, some common use cases are adapting an object type, like maybe a database data, or let's say a data library, payment provider, authentication provider, maybe some sort of CSS and HTML components as well. Really anything where the functionality is similar, but the implementation is a bit different. The API we're calling is a bit different. Like authentication example, where which we will look into the skill build module. So we know that there will be some login, some logout, and some register functionality. And our application should not care about which type of application is it, Google, Facebook, or some other authentication. And the best way of using this design pattern is obviously, as many other design patterns, is beforehand, when we know and expect to support different types of interfaces. Like we know that we might have a different payment provider or different authentication service. We should start with a simple adapter right away so that we can expand on it later. Now, do you remember some of the advantages that we mentioned? One of them is flexibility. If done correctly, we can in theory integrate any library or any object with our application without changing anything in our application. We just write a good adapter and our application will continue to work with it. Second is extendability, because our application logic is in one object. We can change our application, its behavior, and our adapter service as much as we want, and everything will work fine if adapter is correctly implemented. And the next advantage is reusability. We can obviously just reuse existing code we made for some other system or we have found on the internet and just adapt it to our application, if possible, and if it makes sense, of course. And finally, these patterns allows us to extend applications because we can add as many services, API, or libraries that do a similar thing that we want. And if we just add a new adapter, our application can scale quite a lot, and it can support very different maybe backends, API, objects, databases, or whatever we are adapting. It also has some trade-offs, like everything in life, and obviously the one, my favorite, is complexity, right? Because we are now not using the end object directly or end service directly. We need to add another object to do this translation in between objects. This could lead to maybe some difficult debugging and trying to understand what the hell the translator or the adapter does. Another downside that we really need to be sure when this design pattern is so that this design pattern is not misused, and that is denial. We do not want to use this design pattern to hide the real problem. We can easily think that we can just adapt anything to anything and avoid refactoring of our application maybe. Sometimes you need to fix your application, not just grab for the adapter, right? Or maybe you are actually using this adapter to avoid the actual work because it's just much easier to make an adapter and call it a day. So this adapter is not always the answer, right? Otherwise, every application in the world would just use adapters for pretty much everything. Now, the best use of adapter is intentional, and we need to understand what this adapter does and how it works, and when it's used, what are its upsides and downsides, like everything in life. On that note, we could use this adapter as a temporary fix that we are going to migrate something. So we use it as a mean to delay application. However, in reality, we're just delaying the necessary work, right? And that might lead to a lot of technical debt accumulating. So again, use this design pattern only when it makes sense. Use it by your choice, not being forced into it. So use it by design, not as a quick fix, right? And this is why, and pretty much every design pattern like this should be used carefully and intentionally, right? And not as a quick fix to a larger problem.